Dominique from Dominique's Pizza bakes the same amount of pizza every day. She used to spend $8 each day on using the oven and $1.50 on ingredients for each pizza. So $8 each day on using the oven and $1.50 on ingredients for each pizza. One day the price for the ingredients increased from $1.50 to $2 per pizza. Dominique made some calculations and found that she should bake 8 pizzas more each day, so the expenses for a single pizza would remain the same. And assume they're saying the total expenses for a single pizza, because clearly the ingredients cost is not the same. We're talking about the total ingredients. So if we were to spread the cost of the oven across all of the pizzas, write an equation to find how, or the total cost for the oven per day, to spread that across all the pizzas. Write an equation to find out how many pizzas Dominique baked each day before the change in price. Use P to represent the number of pizzas. So let's just think about her total cost per pizza before and then her total cost per pizza after if she bakes 8 more pizzas. So before, we're going to use P to say that's the number of pizzas she baked per day before the change in price. So before the change in price, on a given day, she would spend $8 on the oven and then $1.50 on ingredients for each pizza. So 1.5 or $1.50 times the number of pizzas. This would be her total cost on all the pizzas in that day. It's the oven cost plus it's the ingredients cost. So if you wanted this on a per pizza basis, you would just divide by the number of pizzas. Now let's think about what happens after the change in price. After the change in price, her cost per day for the oven is still $8. But now she has to spend $2 per pizza on ingredients. So $2 per pizza. And instead of saying that she's baking P pizzas, let's say that she's now baking 8 more pizzas each day. So it's going to be P plus 8. And so this is going to be her total cost for all of the pizzas she's now baking. And so if you want it on a per pizza basis, she's now making P plus 8 pizzas, you would divide by P plus 8. And the problem tells us that these two things are equivalent. Here you had a higher cost in ingredients per pizzas, but since you are now baking more pizzas, you're spreading the oven cost amongst more and more pizzas. So let's think about what P has to be. P has to be some number of pizzas so that these two expressions are equal. Her total cost per pizza before, when she only made P, is going to be the same as her total cost per pizza when she's making P plus 8 pizzas. So these two things need to be equal. So we did that first part, or we did what they asked us. We wrote an equation to find out how many pizzas Dominique baked each day before the change in price, and we used P to represent the number of pizzas. But now for fun, let's actually just solve for P. So let's just simplify things a little bit. And actually, so this part right over here, actually let's just cross multiply this on both sides. Or another way of thinking it is multiply both sides times P plus 8 and multiply both sides times P. So if we multiply by P plus 8 and we multiply by P, we multiply by P plus 8 and we multiply by P, that cancels with that cancels with that. On the left-hand side, so let's see, we have to just do the distributive property twice right over here. What is P times 8 plus 1.5P? Well, that's going to be 8P, I'm just multiplying the P times this stuff first, plus 1.5P squared. And now let's multiply the 8 times both of these terms. So plus 64 plus 8 times 1.5, that is 12, plus 12P. And that's going to be equal to, let's see, let's multiply P times all of this business. So that's going to be equal to 8P. 8 times P is 8P. And let's see, I could distribute these terms and then multiply by P. So 2 times P is 2P, times P is 2P squared, plus 2P squared. And then 2 times 8 is 16, times P is 16P. So now we have, well, we essentially end up with a quadratic equation, but let's simplify it a little bit so that we either factor it or apply the quadratic formula. So let's see, let's subtract 2p squared from, actually let's subtract 1.5p squared from both sides. So subtract 1.5p squared, subtract 1.5p squared. Actually, let me just put everything on the left-hand side just because that might be a little bit more intuitive. So let's subtract 2p squared from both sides. Subtract 2p squared from both sides. Let's subtract 16p from both sides. So we have an 8p and a 12p, and then we're going to subtract a 16p from both sides. And then, oh, actually, let's subtract an 8p as well from both sides. We have a 16p and an 8p. So that actually works out quite well. So now we've subtracted 8p from both sides, 16p from both sides. We've essentially subtracted all of this stuff from both sides. And we are left with, let's see, 1.5, I'll do it in degree order. 1.5p squared minus 2p squared is negative 0.5p squared. And let's see, these cancel out. 12p minus 16p is minus 4p. And then we have plus 64, and then that is going to be equal to 0. That is going to be equal to 0. And just to simplify this a little bit, or just to make this a little bit cleaner, let's multiply both sides of this equation by -2. By -2. I want the coefficient over here to be 1. So then we get p squared plus 8p, p squared plus 8p is going to be equal to, let's see, negative times -2. So minus 128 is going to be equal to 0. So let's see if we can factor this. Can we think of two numbers where if we take their product, we get negative 128, and if we were to add them together, we get positive 8. So they're going to have different signs right over here. So let's see. If we say 12 times, let's see, 12 times, well, let's see, what numbers could this be? So if we were to think about 128 is the same thing as, let's see, 16. Let's see, 16 goes into 128. Let me work through this. 16 goes into 128. Does it go 8 times? 8 times 6 is 48. 8 times 10 is 80, plus 40 is 128. Yep, it goes 8 times. So 16 and 8 seem to work. So if you have positive 16 and negative 8, the product would be negative 128. So we can factor this out as p plus 16 times p minus 8 is equal to 0. Now this is going to be equal to 0 if one of these two, at least one of these, is going to be equal to 0. So we have two solutions. Either p plus 16 is going to be equal to 0, or p minus 8 is equal to 0. This one right over here, subtract 16 from both sides, you get p is equal to negative 16. Here, you get p is equal to 8 if you add 8 to both sides. Now, we're talking about a number of pizzas made. So this one doesn't apply. This would be like Dominique eating 16 pizzas or somehow destroying 16 pizzas a day. We're not interested in that solution. So if we want the solution to the original question, the number of pizzas she made before the increase in price, she made 8 pizzas. She made 8 pizzas per day. So p right over here needs to be equal to 8. So before the change in price, she made 8 pizzas a day. After the change in price, she made 8 more pizzas a day, or 16 pizzas per day.